This video tutorial, I'm going to go over handout on Fatima al-Fihri. This handout divides in three parts. Part 1, do now. A student will get 5 minutes to solve 5 problems. And then big idea. Big idea, there are 2 problems. A student will get 10 minutes to solve each problem. And of course, there is an exit slip. The teacher will walk around to offer scaffolding to the student who need help. So let's get started with the do now. The problem number 1 is who was Fatima al-Fihri? Well, Fatima al-Fihri is you see right here on the top. She is next to Sutayat al-Muhammali and above Dr. Hayat Sindhi. She was the Muslim woman who founded the first university in the world, al-Qarawiyyin University in, of course, Morocco, but she was born in Tunisia. The next question is what was her contribution in math education? Well, she was a great teacher. She taught at the same university she founded, 859. She was actually known as mother of boys by the parents of her own students. A great recognition. The next question number 3, is that why she named her own university al-Qarawiyyin University. That takes us to from Morocco to Tunisia, where she was born 800 AD in a place called al-Qarawiyyin. So she wanted to, when she founded the university 859, she wanted to honor the place she was born about 59 years earlier. It's much the same way Marie Curie, when she discovered polonium, she named it polonium because she wanted to honor the country she was born in, 1867, Poland, of course. The next question, that takes us to the next question, how this is going to help with, how the story of Fatima al-Fihri will help the minority student, like Muslim women, Muslim student. Well, her story will help a student with double jeopardy, like Muslim women student in the math class, because when Muslim students see someone like Fatima al-Fihri who looks like them and became as successful as Fatima al-Fihri, then they will have same mindset. They will think that they too can become as big as Fatima al-Fihri, and that's really going to be very inspiring for them to become as big as Fatima al-Fihri, and it's going to help other students to have more inclusive mindset that anybody can become a mathematician, anybody can become a pioneer in education. Of course, that takes us to the last question, and that is what is the connection between Fatima al-Fihri, Jacob Wallace, and then René Descartes? Well, Jacob Wallace went to Morocco to study at University of Qarawiyyin. So he learned mathematics at University of Qarawiyyin, and then he later returned to Europe, and he became teacher of René Descartes. And this is the connection between Fatima al-Fihri, Jacob, and René Descartes. And now we're going to move to big idea, and big idea really starts with factor algebra. So we imagine the year is 1857, 1858, 1859. Fatima al-Fihri spent lots of time observing the construction and supervising the construction of her own university, al-Qarawiyyin University, in a place called Fez, of course, in Morocco, and often her sister Maryam visited her. So and they would be talking about mathematics, and now we are thinking of one day Fatima applied 3 Newton force to an object, and Maryam also started with 3 Newton. So both of them would be 0 degree. So 3 plus 3 would be 6. Now Fatima keep the same angle, but Maryam change the angle from 0 degree to 30 degrees. So 3 Newton, but 30 degree would be this time 5.8. Now Fatima keep the same angle, but Maryam changed from 30 degree to 90 degree. Now this time 3 Newton would give you 4.2 Newton. Now Fatima keep the same angle, but Mariam changed from 90 degree to 120 degree. Now this time 3 Newton and 3 Newton come from Fatima and 3 Newton come from Mariam would give you of course 3 Newton. And finally Fatima keep the same angle, but Mariam decided to change from 120 degree to 180 degree and then become like this. So now this time 3 plus 3 of course is going to become 0. Now this vector algebra we're going to of course do it on the board, and this is you're going to have both 0 degree, and then this one we're going to have 30 degree between two vectors, and this is of course 90 degree between two vectors, and this is 120 degree between the two vectors and 180 degree between two vectors. And remember, one of them is Fatima al-Fihri. She applies 3 Newton, and this is Fatima. She applies 3 Newton. Of course, the unit Newton wasn't around at that time, and we just want to use Newton. We modernize the unit. And then Fatima is also applying 3 Newton, and she doesn't change her angle. She does not change her angle, but you will see that Mariam will change her angle. And if Mariam change her angle, how the sum will be different. We're going to use this would be the Mariam, and Mariam would be applying also 3 Newton, but at the same angle. So Mariam is applying 3 Newton. This time Mariam is applying the 3 Newton with 30 degree angle. So we're going to make it 30 degree angle. So 30 degree angle. I already wrote the 30 degree over there, so I'm just going to write Mariam 3 Newton. This time 90 degree, so I'm just going to write Mariam 3 Newton. This time 120 degree. Notice the angle between these two is 120, as I mentioned over here. Mariam 3 Newton, and this time she decided to use of course a 3 Newton opposite direction, which is of course 180. And now we're gonna predict. So these are the scenarios, and we're gonna make prediction. So in this case, we're gonna get our prediction is gonna be between 0 to 6. Any type of values possible between. So resultant would lie between of course 6 to 0, right? You cannot have 7 or you cannot have -1. It will lie between 0 to 6. Okay, and that's what we're going to prove by of course trigonometry. So this time the resultant would be exactly 6. This time the resultant would be less than 6. This time the resultant would be less than 6, and this time the resultant would be less than 6, and this time the resultant would be 0. All right, as angle, of course we know that as angle it starts from over here. Okay, both angle over here, that means the maximum. If that one angle is moving counterclockwise and it moves to all the way from 0 degree to 30 degree to 90 degree, 30 degree gonna give you the less than 6, and the 90 degree gonna give you much less than 6, and then 180 degree gonna give you 0. So this is what we're gonna be observing. So now let's prove it. Do the math. We can use anything we want, but let's use the trigonometry. Isn't it fun to prove 3 plus 3 is 6 by using trigonometry? Maybe it is. So now we're gonna use red for of course Fatima. So Fatima has x and y, right? So cosine 3 cosine 0 degree. So 3 cosine 0 degree, which is 3, and 3 sine 0 degree, which is 0. We're gonna have this one as well. I'm sorry, use the black. So vector, and this would be for Fatima, a vector, and this would be of course for Fatima, vector, and this would be of course for Fatima, a vector. This would be of course for Fatima. All right. So the Fatima, as you see that 3 cosine 0 degree and 3 sine 0 degree, because Fatima did not change her angle. She did not change her angle. 3 cosine 0 degree, which is 3 sine 0 degree, which is of course 0. 3 cosine 0 degree, which is 3 sine 0 degree, which is 0. 3 cosine 0 degree, which is 3 sine 0 degree, which is of course 0. Now we're gonna see the other one. We're gonna see the Mariam. So Mariam would be, of course, 3. This one. Let's do this one. Mariam would be Mariam x, Mariam y. So 3 cosine 0 degree, which is 3 sine 0 degree, which is of course 0, and then 3 cosine, now all of a sudden 30 degree, and that is 2.6, and 3 sine 30 degree, and that is of course 1.5. 3 cosine 90 degree, which is of course 0, and 3 sine 90 degree, which is 3. This is Mariam, and this is mx, my. 3 cosine 120 degree, and 3 sine 120 degree, and of course the last one, 3 cosine 180 degree, and 3 sine 180 degree, and let's figure it out how much. And this one is 3 plus 3, now 6, and 0 plus 0 is 0. So r is, of course, you have 6 square plus 0 square, and that would be r is of course 6 Newton. X is 3 plus 2.6, which is 5.6 square, plus ry is 0 plus 1.5, which is 1.5 square, which is 5.8 Newton, and that's exactly what we predicted, that r is slightly less than 6, and this is slightly less than 6. So this one gonna be rx. In this case, 3 plus 0 is 3 square, plus 0 plus 3 is of course 3 square. So r is the square root of 18. So r is of course 4.2 Newton. And this is, we said that this is a little smaller than 6, and in fact this is a little smaller than 6. Take us to the next one. R is of course rx. Rx is of course 3 cosine 120 is negative 1.5. So 3 plus a negative 1.5, which is 1.5 squared, plus 0 plus 2.6, which is 2.6 squared, and that is r is of course 3 Newton. And we said that r is way less than 6, and this is 3 is way less than 6. 3 is 3 is half. R is, we claim 0, but let's see what we get. Rx 3 minus 3, because cosine 180 is negative 3. 3 minus 3 is 0 square, plus of course 0 plus 0 is 0 square. So R is 0. In fact, that's what we predicted. Now let's draw the resultant. In this case, this is the resultant, and this is the R. In this case, the resultant would be we have this one, and that is Fatima, and we have this one. We have this one is Mariam, and this is R. R is in this case, of course, 5.8, as you see, and this is 30, so this must be 150. In this case, you see that this is Mariam, this is Fatima, this is Mariam, and this is of course the R, which is 4.2. In this case, this is Fatima, and this is Mariam, and this is, and the R is 3. In this case, there is no R, and therefore the R is 0. I'm gonna of course draw them in red. So this is the R, this is the R, this is the R, and this is the R. In this case 3, in this case 4.2, in this case of course 5.8, in this case of course C should be longer. All right, so this is the biggest, then second biggest, and then the third biggest, and then the fourth biggest, and this is 0. All right, so r is getting smaller and smaller and smaller as the angle getting bigger and bigger and bigger between the big idea number 2, Fatima apply 32 Newton on an object at 90-degree angle, and Mariam apply the force of 20 Newton, and the 32 Newton and 20 Newton, there are 20 Newton below 30-degree below the x-axis. So then 90-degree above the x-axis, 30-degree below the x-axis. So there are 120-degree between these two vectors. Now we're gonna, of course, do it by all type of mathematics. We're gonna do it 7 or 8 ways. First, we're gonna do it by protractor, and then we're gonna do it by parallelogram, law of cosine, law of sine, and then we're gonna do it by trigonometry. We're gonna do it by geometry. We're gonna do it by, of course, the distance formula. A is 32 Newton, and then B is 20 Newton. Of course, when you take the ruler, you measure it, and you see that A is 8 centimeter and B is 5 centimeter. And I ask you, 1 centimeter is equal to how many Newton? That's the problem I ask you. Now, there are many ways of solving this problem, but the easy way is, right, 8 centimeter is equal to 32 Newton. It is equal to 32 Newton. That means you divide both sides by 8. And so 8 cancel, 8 goes to 32, 4. So 1 centimeter is equal to 4 Newton. So you report what you see, 1 centimeter is equal to 4 Newton. You can also do it this way, and you can write 5 centimeter is equal to 20 Newton. So divide both sides by 5. So 1 centimeter is equal to 4 Newton. You verify it. Now you're going to draw it to the scale is because I'm going to hold you responsible to draw things to the scale. So let's draw the first vector. First vector is 8. I'm going to multiply it by 3. So 24. This next vector is 5. I'm going to multiply 3 by 15 Newton. So the first one is 24 Newton. So I'm going to exactly have 24 Newton, no more, no less. All right. Now, make sure you know how to draw this thing to the scale. I'm going to take the protractor. I'm going to make sure I have 120 degree. So this is my 120 degree. Okay. So I'm going to make a line from here to here, and that is my, I want to make sure that this is 15 centimeter because this is 24 centimeter. This 24 centimeter I'm going to call 32 Newton A. This 15 centimeter, I don't even know whether this is 15 centimeter, so I have to verify it. So I have to verify whether this is actually 24 centimeter, 15 centimeters. So this is 15 centimeter. 15 centimeters right here. Okay, now I have to make sure that this angle is, of course, 60 degree. So I put a hole over here on the arrow. There is a small hole on the protractor. All right, and then I put the dot at 60 degree. So this is the 60 degree AC. This is the 60 degree. All right. So now I'm going to connect this to arrow or dot as big as possible. And I'm going to make 60 degree over here as well. So put the hole over here. And 60 degree is right here. So I'm gonna draw a line over here, also as big as possible. All right, so now since I have this is like a pencil I can erase, so make sure I have the arrow. If you don't have the arrow, then you are wrong. Then I don't know what you have. They are not vector. No arrow, no vector. All right, this is drawn to the scale. Now the next thing you're going to do, you're going to draw the resultant. You have this is A, you have this is B. You know A is 32, B is of course how much? 20, and you're going to see the resultant. So this is, make sure you have the arrow. If you don't have arrow, you don't have resultant. And of course you're going to say R and hat. So this is your resultant. Now you're going to take the ruler to find the size of the resultant. Since you draw it to the scale, you should get the correct size. So this is 21. So I'm going to go ahead and write 21 centimeter. Divide by 3, so it's 7 centimeter. Why I divide by 3? Because I multiply by, of course, 3. That's why I divide by 3, 7 centimeter. Now I'm going to write R is equal to 7 centimeter. And of course, centimeter is bottom, Newton at the top. 1 centimeter is, of course, 4 Newton. How do I know? From here, centimeter cancel. So resultant is 7 times 4, 28. And there is a Newton as a unit. Put the arrow on the top. So this is how you're going to do problem number 1. Now let's go over problem number 2 by parallelogram. So now again you want to write this one. This is a law of parallelogram. Law of parallelogram. So you're going to write R squared is equal to A squared plus B squared plus 2AB cosine R. Or cosine theta, doesn't really matter. So R squared is equal to 32 squared plus, always remember this angle which is given 120, this is also 120, this is 60, this is 60. This is always parallelogram. This is always parallelogram. This is always law of cosine, and this is always law of cosine. So what do we learn? Tail and tail is parallelogram, head and head is parallelogram, head and tail is law of cosine, and head and tail is law of cosine. Okay, 20 squared plus 2 times 20 plus times 32 cosine, you have to use 120. So R squared is equal to 32 squared plus 20 squared plus 2 times 20 times 32 minus half. So R is equal to 28 Newton. So this is how you're going to find the resultant using, of course, the law of parallelogram. Now we're going to use the law of cosine. Law of cosine would be also very easy. So now let's do it by using other color. R squared is equal to A squared plus B squared minus 2AB cosine 30. So since you're using law of cosine, you have to use the head and tail method, and you used to use the head and tail. So head and tail is what? 60. Head and tail is what? 60. All right. So R squared is equal to 32 squared plus 20 squared minus 2, 32, 20, and this is half. So R is 28 Newton. So now we're going to do the geometry. To do the geometry, you see that it is super easy. What we're going to do over here is this. You're going to use 30, 60, 90, properties of 30, 60, 90. So this is your, of course, by, because this is your b, and b is, of course, you see b is 20, and this is your bx. If this is 120, this has to be 60, and this is 60, this has to be 30. All right, so now what I'm going to do, I'm going to copy and paste. All right, so this one is 60 degree, so I'll write 60. This one is 30 degree, I'll write 30. This one is 90 degree, I'll write 90. Opposite to 90 is 2x. Opposite to 60 is x root 3. Opposite to 30 is, of course, I don't know, x. So 2x is equal to how much? 2x is equal to 20. 20. So x is equal to 10. So 10 square root of 3 is 17.3 and 10. All right. So now it's easy to find it by geometry. So you have a black line, which is what? 32. You have a red line, which is how? By is, of course, 10. 10. So 32 minus 10 is, of course, 22. So we have 22. And then you have over here is bx, which is 17.3. 17.3. And now you have to find the r, and which is very easy. So r square is 20. I don't know why. Let's see. It's something. 70.3 square, and that is 28 Newton. Next, we're going to do it by law of sine. Let's use law of sine. To do the law of sine, what we're going to use, I'm going to use this. You see the red over here? I want to just copy and paste this side. This red doesn't work. So you see this red. I'm going to draw this red. Let's first draw this black vector. Draw this black vector, and how much is this? Of course, a, which is 32. So let's call it 32. Draw this also black vector. B is 20. So let's write 20. Draw this red vector. We don't know how much it is because we are using law of sine. We're gonna find it. So we're just gonna call R. This is our result. What else we know? We know this angle. If you use the protractor, and I'm gonna use the protractor. I'm gonna place it like this. Place it like this. And it's going to tell us this is 40. This is 40. So if this is 40, this must be 80. All right. That means this is 80 and this is 40. Interior opposite angle are congruent. So 40, 40. 80, 80, 60, 60. Notice this is not a right angle triangle, so you cannot use SOHCAHTOA. This is not a right angle triangle, so you cannot use a square plus b square equal to c square. No. No Pythagorean theorem, no SOHCAHTOA. What you can use? Or you can use a law of sine. You can call it A. If you call it A, you must call it A. If you call it B, you must call it B. So of course now we have everything we're looking for. So of course you are solving for R, so put the R over here. So you can call sine R. So this become all sine R is equal to, let's talking about A. So A is sine A. So R is what we're looking for. Sine R is of course sine 60 is equal to A. What is A? A is 32 over sine A. What is sine A? Sine 80. If you do cross multiplication, you get R is equal to 32 sine 60 over sine 80. And which give you, of course, 28 Newton plus minus 1 Newton. Because I asked you that, I would accept only 5% error. Only 5% error, so you cannot put 2. 5% error means 1. Because if this is a true answer, which it is, then it could be 27 Newton or 29 Newton. Both is true because both falls within 5%. How do you know? This is your, say this is your measurement minus the true value. This is your measurement minus the true value. Divide by true value. Divide by true value. Times 100%. Times 100%. Alright, and this is give you 3% error. And of course 3% error, this is also give you 3% error. 3% error is less than 5% error. So I'm good with this. However, if you put 2, it's not gonna give you 3% because all of a sudden this is gonna become 26 and this is gonna become 30. Then the answer gonna changes. Of course, you are talking about absolute value. This becomes 7% error and 7% error. And I do not accept 7% error. 7% error is not less than 5% error. So this I don't accept. I accept only 5% error because you have more skill now. In the beginning, I accepted, of course, 10% error. Now I accept only 5% error. Now let's do it by trigonometry. So many people made mistake with the trigonometry, not sure why. All you needed to do is use the trigonometric tree diagram that I gave you. So, alright, so this is what you have, and I'm gonna erase everything to make it look better. So this is what you have. Okay, so this is what you have. This one is, of course, B, and B is 20. This one is A, and now A is 32. Okay, so you have a vector B or vector A and B. A has AX and AY. B has BX and BY. Talking about AX, but before you do anything, you have to make sure that there is a X and Y. So let's draw X and Y for you by PowerPoint. This is your X. This is your Y. Always you're going to be imagining X and Y. If you don't, no good. So what are you going to be writing? You're going to be writing, of course, which one you want to start with. Let's just start with A. I ask you, hey, put your protractor over here and measure the angle counterclockwise. If you do with respect to X, then it's 90. So since A is 32, so 32 cosine 90. 32 sine 90. And B, you can measure it like that. Of course, you can measure it like that. If you do, it's tricky to measure it by protractor. But one thing you can do, you can measure this one. this is going to give you negative 30, which is negative 30 because this is clockwise. So you can write, this is B is 20. You write 20 cosine negative 30, or you can write 20 cosine 330. They are the same thing. Okay, they are the same statement. Now By, of course, you're going to write 20 sine negative 30 or 20 sine 330. Of course, this is 0 and this is going to give you 32, and this one going to give you 17.3, and this one going to give you negative 10. Negative 10. Calculator will give you. Alright, so this is your x. So you write ax, resultant is, first add them up, ax plus bx, which is going to be your rx. Ry would be bx plus by. What is your ax? 0. What is your bx? 17.3. So rx is 17.3. What is your bx? Bx is what is it? By ay. What is your ay? Ay is 32. What is your by? By is negative 10, which is 22. All right, excellent. So now you know everything. You know your r square, or r is equal to rx square plus ry square, and this is 17.3 square, and this is 22 square. So your r, make sure you show the r. If you don't, then you lose point. Your r is again 28 Newton for the above reason. All right, now I'm going to use a distance formula right now. To do the distance formula, all I need to do is very simple. I'm going to come over here. This is my b. I need the y component of the b. So this is the y component of the b. So I write b, y. And this is the x component of the b. So I write bx. So now I have y component of a, ay, y component of the b plus by, okay, is equal to ry. I have x component of the a, 0, we'll write it down, plus x component of the b, which is rx. Ay is 20, ay is 32, by is 10. All right, how it is 10, you're probably thinking. It's 10 because we already explained it. So by is negative 10 because the arrow is down, negative 10. So this is 22. This is 0. This is 17.3. So this is 17.3. So I have 22 and I have 17.3. I have the resultant. So this 0, 0, and this one is 17.3, 22. So the distance formula, as you know, which is of course r r is square root of x2 minus x1 square plus y2 minus y1 square. So r is, this is x1, this is y1, this is x2, this is y2. y2 is, x2 is 17.3 minus 0 square plus y2 22 minus 0 square. So r is equal to 17.3 square plus 22 square. So r is of course 28 Newton. So we are done with this two vector problem. Now we're going to do one more thing, and that is called why we have to use the uncertainty. And what does that mean when we are talking about 1% or 2%? So problem 1, since we have to do the hand measurement, so this is A is 32 and this is B is 20, and we have to do hand measurement. So this is A is 32 and this is B is 20. We have to do the hand measurement. So however, I ask you to use the ruler and the protractor. So there will be human error but less. That's why I said that 5% would be acceptable. And the true answer is 28 Newton, because it's 7 centimeter. 1 centimeter is 4 Newton. There are 4 vectors. Vector 1, vector 2, vector 3 and vector 4, and we have a grid, right? We have an X and Y. So we're going to use head and tail method to place this vector, and we're going to finally draw a resultant vector. We're going to use the blue to draw the resultant vector.
Okay.
So first I'm going to draw this and you're going to draw the resultant vector. How about that? So let's count the first vector. 4, 2. Can you show me where is 4, 2 is?
Well, we have 1, 2.
No.
Oh, sorry. 0, 1, 2, 3, 4, comma 1, 2.
That is correct. So that's 4, 2. Let's connect them. 4, 2.
Ooh.
That's correct. Now go to the head of vector 1 and can you count -2, -5?
All right. Well, -2 in the x would be 1, 2, and then -5 would be 1, 2, 3, 4, 5.
That is correct. So this is our new head. So you're gonna keep getting a new head. In real life, if you keep getting a new head, it's gonna be pretty annoying, stressful. The vector 3. Go to the new head of vector 2, and let's count -5 plus 5.
All right. Well, we have -5, so 1, 2, 3, 4, 5 plus 5. 1, 2, 3, 4, 5.
That is correct. So we have a new head emerging.
Wow, that's disgusting.
All right. Okay, so we got a new head of vector 3. Do we have one more to go?
Yep.
All right, let's go.
All right. So we have y, which is 1 in the x direction, so right over here. Then -5 in the y, so 1, 2, 3, 4, 5.
All right, so we have now 2. This is the last one, I believe, right?
Yep.
All right. Okay, so we have a new head. Now you're going to draw the resultant. What would be the resultant? You want to show me?
Well, the resultant here would be this.
Yes, that's the resultant. Hold on. I'm going to hold it. Okay,
Bam.
that's the resultant. All right. All right, make the resultant a little nicer. Okay. All right. So what would be the resultant x and y? Can you please write them?
Well, what we do to find the resultant x and
You
y
want to do it
is
that way?
add it. Okay, so we have 4 plus 1 is 5, -5 is 0, -2. So the x is -2. Then we have 2 minus 5 is -3, plus 5 is +2, -5 is -3.
All right. So let's see that. You said -2 is x, right?
Yup.
1 and 2.
2.
So -2. That's correct, right?
Mm-hmm.
And then -3. Fall how much?
1,
1, 2,
2, 3.
That's correct. Now, you're going to use Pythagorean theorem. Pythagorean theorem is fine. So square root of 13 is 3.6 meter, and this is 3.6